Hello everyone, I'm Rajasri, Assistant Professor of Department of EEE working at MLR Institute of Technology, Hyderabad. And in today's video, we'll be seeing the problem solved on series and parallel connection of SCRs. And here are some of the formulae which we have already derived in the previous videos. These are important formulas in order to solve the problems. So here is a problem which we have. How many SCRs are required? See, before solving any problem, we need to first write down the given data so that it will be easy for us to solve any problem. And here, how many SCRs are required in series string to withstand a DC voltage of? So let me write down the given data where Vs is equal to 3500 volts. If the SCRs have steady state voltage rating of, that is VD1 is equal to 1000 volts. Derating factor is 30, percentage derating factor is 30. Assuming maximum difference in leakage current, that is leakage current delta ID, it is denoted with delta ID, which is equal to 10 milliamperes. Calculate the value of voltage sharing resistances to be used. That is how many number of SCRs, we need to find out the value of N as well as the value of voltage sharing, that is the value of the resistance which is to be connected should also be calculated. And here, in order to calculate the N, I am considering the formula for derating factor, where derating factor is equal to 1 minus string efficiency into 100. Where string efficiency, we have already seen the formula. String efficiency is given by Vs by N into Vd1 into 100, where derating factor, percentage derating factor is given by 30. 1 minus Vs is 3500 volts divided by N is, we need to find it out, and Vd1 is 1000 into 100. If you resolve this equation, we get N is equal to 5. That is one parameter which he have asked. And the other thing is, we need to find out the value of the resistance. For that, we have a formula, N into Vd1 minus Vs by N minus 1 into delta ID. Here, number of SCRs are 5 into Vd1 is 1000 minus Vs string voltage is 3500 divided by number of SCRs are 5 minus 1, 4 into delta ID is 10 into 10 milliamperes, that is 10 into 10 to the power minus 3. We get R value as 37.5 kilo ohms. 37.5 kilo ohms. Next problem. See here 10 thyristors. Let us write down the given data first for the second problem. Here 10 thyristors, in the sense N is equal to 10 and voltage Vs is equal to 15 kilovolts. Maximum leakage current and recovery charge difference. Leakage current is given by delta ID, which is equal to 10 milliamperes, and charge difference, it is given by delta Q, which is equal to 150 microcoulombs. And each thyristor has a voltage sharing resistance of, we have R is equal to 56 kilo ohms and into 10 to the power of 3 ohms, and capacitance C1 is equal to 0.5 microfarad. And here he is asking you to find out maximum steady state voltage sharing, that is given by VDS maximum. We denote it with VDS maximum, or we can also say it as VD1, where we have already seen the formula for VD1, which is equal to Vs plus N minus 1 into delta IDR divided by N. Vs is equal to that is we have 15 kilovolts ante 15,000 volts plus n minus 1, 10 minus 1 into delta ID is 10 into 10 to the power of minus 3 milliamperes. Resistance is 56 kilo ohms into 10 to the power of 3 divided by n is 10. Yeah, if we resolve this, we get VD1 is equal to 2004 volts. Similarly, the second bit is calculate steady state voltage derating factor. Derating factor, second bit, derating factor, it is given by the formula D is equal to 1 minus eta, where eta is equal to, since this is series connected string, Vs by N into VD1 into 100, where Vs is equal to 15,000 volts divided by N, number of SCRs are 10, into VD1 is given by 2004, which we have got previously, 2004 into 100, where derating factor it is given as, so here derating factor value is 25.15%. This is nothing but steady state voltage derating factor. And the third bit we need to resolve is maximum transient voltage sharing, VDT maximum, which we can also call it as VD1, where we have the formula VD1 is equal to Vs plus N minus 1 into delta ID into R, is it not? In place of delta ID into R, I am substituting delta Q by C1 by N, because this is maximum transient voltage. So here let me substitute Vs is equal to 15,000 volts plus N minus 1, that is 10 minus 1 into delta Q is 150 microcoulombs divided microcoulombs 150 into 10 to the power of minus 6, and capacitance value is 0.5 microfarad, that is into 10 to the power of minus 6 divided by N, that is 10. In that case, we get this maximum transient voltage sharing as 770 volts. This is nothing but your VDT maximum or VD1, transient voltage sharing. And similarly, we need to find out the transient voltage derating factor. Transient voltage derating factor, that is given by D, where D is equal to 1 minus string efficiency, where string efficiency is Vs by N into VD1 into 100, where 1 minus, here I am substituting the value of transient voltage, that is Vs's string voltage is given by 15,000 volts by N is 10 multiplied by this VD1. I am considering the transient voltage, that is 1770 into 100. And if you resolve this equation, we get 15.25%. And the third problem we have, let me write down the given data in the similar manner. String of series connected thyristors to withstand the DC voltage of Vs is equal to 16 kilovolts here, and maximum leakage current and recovery charge difference. That is leakage current, it is given by delta ID, which is equal to 10 milliamperes, and charge difference, it is denoted with delta Q, which is equal to 100 microcoulombs respectively. And the derating factor for steady state and transient voltage sharing are percentage derating factor, it is given by 20 for a maximum steady state voltage sharing of 1 kilovolts. Let us denote this with VD1 is equal to 1 kilovolt. And here he is asking you to find out the value of the resistance as well as the suitable value of the capacitance. And for which, in order to calculate R, we need the value of N, right? So let us find out the value of the n from derating factor, where derating factor, it is given by 1 minus string efficiency, and this is a series connected string which is given by 1 minus Vs by n into Vd1 into 100, and derating factor is 20, which is equal to 1 minus Vs is 16,000 volts divided by n into Vd1 is given as 1 kilovolts, that is 1000 volts multiplied by 100. We get n is equal to 20 in this case if you resolve this. And once we get n, now we can find out the value of the resistance, right? Where R is equal to, we have a formula, n into Vd1 minus Vs, which we have already solved, right? N into Vd1 minus Vs by n minus 1 into delta ID. And if you substitute the given data here, n is 20 and Vd1 is given as 1000 volts minus Vs. Total voltage of the string is 16,000 volts divided by n minus 1 is 19. Let me write 20 minus 1 into delta ID is 10 into 10 to the power of minus 3. In that case, we get the value of the resistance as 21.052 kilo ohms. If you resolve this, you will get resistance as so much. Once we get resistance, we yet need to find out the value of the capacitance. Capacitance, it is given by the formula n minus 1 into delta Q divided by n into Vd1 minus Vs. This is the formula in order to find out the value of the capacitance. Let me substitute the value, that is 20 minus 1 into delta Q is given by 100 microcoulombs into 10 to the power of minus 6 divided by n is 20 and Vd1 is 1000 volts minus Vs is given as 16,000 volts. And if you resolve this, we get 0.475 into 10 to the power of minus 6 microfarad. Yes, let us solve one last problem. Two SCRs are connected in parallel. Here n is equal to 2. It is given as n is equal to 2, and first time we are solving the parallel circuit. Previous three problems were series. So here parallel, supplying the current of 600 amperes. Let us consider the circuit. See, this is T1 thyristor 1 and this is thyristor 2. And to this, we have applied a current of 600 amperes. This is thyristor 1, this is thyristor 2. And VT1 is given by 1.5 volts and VT2 is given by 1 volt. Let me write down here. Total current of the string IS is equal to 600 amperes. And voltage drop across thyristor 1. VT1 is equal to 1.5 volts. VT2 is equal to 1 volt. For the current difference of 10%. That is, current is given by 10% of I2 minus I1, which is equal to 10% of 600 amperes. 10% of 600 amperes. We get it as 60 amperes. So here, let me for current difference of 10%, the resistance connected in series with each SCR. That is, we need to find out the value of the resistance which is to be connected. So we have already seen in the derivation the value of the resistance. It is given by the formula VT1 minus VT2 divided by I2 minus I1, where VT1 is given as voltage across the thyristor 1, it is given as 1.5 volts minus voltage across thyristor 2, it is given as 1 divided by I2 minus I1, that is 60 amperes we have got. So we get 0.5, that is 1 by 120 ohms. This is the value of the resistance which is to be connected in order to balance the current flow. That is static equalization resistance value. In the upcoming lecture, we will be seeing snubber circuits. Thank you one and all.